Welcome to Math to Find. In today's lesson, we'll dive into the world of exponents with a special focus on zero and negative exponents. We'll learn how to understand them and apply them to simplify expressions. Let's start with a quick review of exponents. An exponent tells us how many times to multiply a number by itself. For example, 3 squared, or 3 to the second power, means to multiply 3 by itself twice. If we had 3 cubed, we would multiply 3 to itself 3 times. What about just the number 3? Does it have an exponent? Yes, it does. When you don't see one, it means the exponent is a 1, indicating just one 3. But what about negative exponents, like 3 to the negative second power? How do you multiply 3 by itself negative 2 times? The answer is you don't. A negative exponent tells us to use the reciprocal of the power. First, let's look at 3 to the negative second power written as a fraction. To find its reciprocal, we flip the fraction to get 1 over 3 to the positive second power. Taking the reciprocal changes the exponent from negative to positive. Then, to calculate the value, we multiply the base of 3 in the denominator by itself 2 times, resulting in 1/9. Let's try this again with 3 to the negative third. First, we write this power as a fraction. Then we take its reciprocal to change the negative exponent to a positive 3 in the denominator. Finally, we calculate the value, resulting in 1 over 27. Now let's look at this power, where the base is negative 2 raised to the negative fifth power. How do reciprocals work with a negative base? We follow the same process as before. First, we write the power as a fraction, then take its reciprocal to convert the exponent to a positive 5 in the denominator. Be careful here not to change the base from negative 2 to positive 2. The reciprocal process only affects the exponent, not the base. To calculate its value, we multiply the base of negative 2 by itself 5 times, resulting in the fraction negative 1 over 32. Let's practice solving some expressions. Here we have the fraction 2 to the 6th over 2 to the 8th power. We can use the quotient of powers rule since the powers have the same base. We'll keep the base of 2 and subtract the exponents, resulting in 2 to the negative second power. Since the exponent is negative, we need to simplify further by using the reciprocal process to make the exponent positive, giving us 1 over 2 squared, which simplifies to 1/4. In this fraction, the bases in both the numerator and the denominator are negative 3. And since the bases are the same, we can use the quotient of powers rule again, keeping the base of negative 3, then subtract the exponents, resulting in negative 3 to the negative first power. Since the exponent is negative, we need to simplify a little further by taking the reciprocal of the power to change the exponent from negative 1 to positive 1, keeping the base as negative 3. While this is a legitimate fraction, it does look a little odd written this way. So we'll clean it up by dropping the exponent of 1 and writing the negative sign to the left of the fraction, resulting in negative 1/3. This time we have the fraction 3/4 raised to the negative second power. Since the exponent applies to the entire fraction, our base is positive 3/4. So what do we do with this negative exponent? Remember, a negative exponent tells us to use the reciprocal process. So when we flip the fraction to take the reciprocal of 3/4, we get 4/3, which converts the exponent to positive 2. We calculate its value by multiplying 4/3 to itself 2 times, resulting in 16/9 or 1 7/9. Next, let's look at a fraction where the negative exponent is in the denominator. Do we still need to convert this exponent to simplify it? Yes, we do. We need to use the reciprocal process to convert the negative exponent to positive. The reciprocal of 1 over 9 to the negative second power is 9 squared over 1, which simplifies to just 9 squared. Now we can calculate it by multiplying 9 times 9, resulting in 81. Now this fraction is a bit different. The negative exponent in the denominator applies only to the base number 2. To truly understand how the exponent affects the expression, I'll write it out in expanded form so you can see the math in action. I'll start with the numerator 3 and write it as 3 over 1. Then I'll multiply it by 1 over 2 to the negative second power. This makes it clear which fraction has the negative exponent. Next, we'll bring over 3 over 1 and take the reciprocal of the second fraction, resulting in 2 squared over 1. We can simplify this to 3 times 2 squared, which equals 12. All right, now we have negative exponents in both the numerator and the denominator. Let's write this problem out in expanded form as well. Starting with the numerator, we have 4 to the negative 2 over 1, which we will multiply by 1 over 3 to the negative third. By expanding it this way, it's easier to see which fractions have negative exponents. Since both fractions have negative exponents, we need to take the reciprocals to make the exponents positive. This results in 3 cubed over 4 squared. Simplifying further, 3 cubed is 27, and 4 squared is 16. Finally, we reduce this improper fraction by dividing 16 into 27, resulting in 1 and 11/16. If you enjoy our content and want to support us, here are a few ways you can help. Subscribe to our channel. Send us a super thanks. Leave a comment with your thoughts or questions. Like our videos and share our videos with friends, family, or on social media. Thank you for being a part of our journey and helping us grow our amazing community. Now, let's mix things up by adding some variables and some shortcuts. When working with exponents, it's crucial to identify the base for each exponent first. In the numerator here, the exponent of negative 3 only applies to its base of y, not the 9. The 9 is the coefficient being multiplied by this power. As we've seen before, a negative exponent needs to be changed into a positive exponent before simplifying. Instead of expanding everything out this time, let's use a shortcut. I can change the negative 3 exponent to positive 3 by placing y to the negative 3 in the denominator, keeping the 9 in the numerator, and bringing over the y to the 5th power. Next, I'll simplify the denominator by using the product of powers rule, keeping the base of y and adding their exponents. This results in 9 over y to the 8th power. To simplify this fraction, we need to start with the numerator. Here we have 2 powers with the same base being multiplied, so we can use the product of powers rule. We will keep the base of n and add their exponents, resulting in n to the negative third power over 6. To simplify further, we can use a shortcut and move the power of n to the negative 3 to the denominator so that it becomes n to the positive 3. We need a number in the numerator as well, which is 1. Simplifying the denominator results in 1 over 6n cubed. Now let's look at this expression. When we see a power written this way, the exponent of 2 outside of the parentheses needs to be distributed to both the coefficient of 4 and the variable x to the negative 5th power. Then we can use the power of a power rule to simplify. Before we start distributing the exponent of 2, remember the coefficient 4 has an exponent of 1, even though it's not written out. Using the power of a power rule, we keep the base of 4 and multiply the exponents, and we do the same for the variable x. This results in 4 squared times x to the negative 10th power. Next, we need to eliminate the negative exponent by moving x to the negative 10 to the denominator, while 4 squared stays in the numerator. The final step is to simplify 4 squared by multiplying 4 by 4, resulting in the fraction 16 over x to the 10th power. Now let's see what happens when powers are simplified to result in an exponent of 0. But before we begin simplifying, let's take a moment to examine this fraction. The numerator and the denominator are the same, so we know 2 things. First, a fraction is also a division problem. And second, any number divided by itself is always equal to 1. So 6 to the 4th over 6 to the 4th is equal to 1. Now let's see the math in action. To simplify this fraction, we will use the quotient of powers rule. This rule states that when the bases are the same, we keep the base and subtract the exponents. Subtracting 4 minus 4 results in 6 to the 0 power. But you might be thinking, wait, didn't we just see that 6 to the 4th over 6 to the 4th is equal to 1? Yes, we did. And this is why I chose this example to show you that any value except 0 with a 0 exponent is always equal to 1. Let's look at this fraction one more time to show you why this is true. Writing numbers out in expanded form is really helpful in understanding mathematical rules. So let's start by writing the numerator and the denominator in expanded form. Next, we can cancel out all of these 6's, resulting in 1 over 1, which simplifies to just 1. So the next time you see a power with an exponent of 0, you'll know it is equal to 1. However, you need to also remember that if you see a power with a base of 0 and an exponent of 0, it is never equal to 1. In this lesson, we learned that when dealing with negative exponents, taking the reciprocal of the base makes the exponent positive. For a negative exponent in the denominator, use the reciprocal process by moving the base to the numerator, making the exponent positive. For expressions with negative exponents in both the numerator and the denominator, convert both by taking their reciprocals and then simplifying the resulting expression. And don't forget, we also learned that any power with an exponent of 0 is equal to 1, except when the base of that power is 0. If you stayed until the end of this video, thank you and congratulations. I know exponents can be confusing, so I hope this lesson helped you out. Until next time, keep math awesome.